Good morning, everyone. Our next session features NewSpace Ignitor Company pitches, highlighting emerging innovators across the space ecosystem. In the first 3 years, NewSpace has supported 50 companies to over $3 million in wins with government contracts and investments. Following the preparations, the companies will be showcased in what we call a show space. Alrighty, next we have Desert Works Propulsion.
Morning. Hi, I'm Pat Patterson here with Desert Works Propulsion. I am joined with our founder and chief engineer, Michael Patterson. We are a gridded ion propulsion company based out of here in New Mexico, right? Awesome, yeah. So Desert Works Propulsion, we advanced gridded ion propulsion, proven electric propulsion technology to meet today's space needs. And that matters more than ever now because, as you're probably not surprised, space maneuver is becoming a warfighter requirement. The U.S. needs spacecraft that can reposition, retask, and persist. As General Whiting put it, the force that can maneuver holds the initiative. And that points to a big problem right now, which is that no current propulsion options exist that can do that. There's none that have the high delta V, high total impulse, and longer life needed. And that is the propulsion maneuver gap. And electric propulsion, as we know, is a proven technology, but what's missing is that it needs to be advanced and optimized to increase maneuver margin over time. Gridded ion can actually solve that gap, and I'll turn over to Michael to explain a little more about why that is.
Gridded ion thrusters are not speculative physics, right? They've flown. Conceptually, they're simple. I won't go into the details on the left-hand side, but conceptually, the simple building flight hardware is a little more difficult. But it's been around for quite a while, so the known unknowns are well understood. So this technology has been flown on some of the hardest missions ever conceived, including the Dawn mission. It demonstrated the highest total impulse of any space propulsion technology ever, first on Deep Space One and second on Dawn mission, where we demonstrated 11 kilometers per second. The point of this technology is that it's well proven, well understood, and quite capable. So the physics are proven. The gap is mission fit for sustained maneuver. So let's talk about the two of the most used technologies, Hall thrusters and gridded ion thrusters. I'm intimately familiar with both. I was responsible for the delivery of the cathode for the U.S. military flight of a Russian Hall thruster through SDIO under Dr. Lynn Cavaney. So I'm a fan of both technologies. Hall thrusters are excellent if the transfer time is a high priority, but gridded ion thrusters are most valuable when you're looking for high delta V, high specific impulse, high total impulse requirements. That's where the sustained maneuver transfer or gridded ion thruster delivers the most capability. We can deliver factors higher total impulse, which translates into maneuver capability compared to Hall thruster technology. And that's really the mission fit case for gridded ion thrusters. And additional attention needs to be applied to that technology for application to Earth orbital and cislunar space.
Yeah, and then that's why our team matters here, where the team behind NASA's gridded ion heritage is the team that's now at DWP. We have Michael has over 38 years experience at NASA. Around him, we have a team of experts, some noted here, that cover things like design, testing, fabrication, and integration. And that's what sets us apart. We have world-class expertise, and we have flight heritage that we can turn into U.S. hardware. Our aim is to channel that 200 plus years of expertise into programs and commercial execution. So we're actually already executing. On the government side, we support the U.S. Space Force Advanced Next program through Voyager, where we do design, cathode development, and life modeling. We recently just finished a thermal cycle test for a flight-like cathode, which you'll see on the picture on the left, and firing with the thruster there on the right. And on the commercial, and then within that, we were able to demonstrate a 40% increase in thrust density to 7 kilowatt input power, which hasn't been done before. And on the commercial side, we are developing the entire propulsion system for Turion Space. And we're in talks right now with another prime to build a variant of that propulsion system for them to use internally. We've also self-funded our infrastructure to move fast. So we have a vacuum test facility here in Carrizozo, And we're working with Dan Schatzman and Jaguar Precision Machine to create a facility here in Albuquerque as well. So we're not a concept company. We have real hardware and real funded work. And our execution can also compound. So we have 4 exclusive NASA licenses that is a path to higher power, including the Annular ion engine, which has shown up to 4 times thrust density increase and can power up to 10 times. In addition to that, we have a patent pending modular design architecture to reduce design burden so we can adapt to other powers more quickly. And we back all of that execution, as we said, with our testing, with our test facilities, so we can iterate and move quickly. And we're also partnering with Jaguar Precision Machine here in Albuquerque, which is a manufacturer that's AS 9100 certified. So our ask here is pretty simple. Engage, fund, partner, invest to mature gridded ion for the commercial and military needs. For government and mission owners, we can help define the propulsion requirements and clear a path to qualification. For a spacecraft company, we can help secure our expertise for mission fit integration, and for investors, you can back the team, the IP, and the build path we have here today. So again, space maneuver is becoming a critical warfighter requirement, and Desert Works Propulsion is ready to advance gridded ion now to meet that U.S. demand. So thank you.